Bangalore, India. And so I'll be taking e-presentation about the paper ID 2506170 managing cost uncertainty in production using genetic algorithm. So I am the first author, Dr. Niju, and my co-author is Redha, Jasim, so we will move on to the paper presentation. And so the paper of interest here is the it was published in the year 2017. The title of the paper is Managing Cost Uncertainty in Production Using Genetic Algorithm. So coming to the introduction part, so here we are trying to give introduction that efficient and effective management of production cost is carried out by understanding the uncertainty in production planning. So what are the uncertainty factors, how it will affect our production process and manufacturing process, like if I minimize the supply chain cost, what will happen, if I minimize the labor, material and other factors, what will be achieved. All these things are taught and understood in this paper. And so here, coming to the point of supply chain, there are many entities in the supply chain. For example, we have to get the raw materials, we have to convert the raw materials into end products, and then we have to deliver the end products to the retailers. So how to improve the overall performance of the supply chain is that we have to make a coordination between different factors. So what is a supply chain mainly is that it involves a set of procedures that is responsible for integration of suppliers, manufacturers, warehouse and stores. And so considering that there are a lot of factors in uncertainty factors, there are 8 uncertainty factors that are there that will affect our delivery performance. They are the late supply, internal and external, planned setup time exceeding, machine breakdowns, labor unavailability, tooling. All these things are responsible for what we call as the uncertainty factors. Also, the concept of yield factor, it is very important. That is, it will lead to uncertainties. So what is a yield factor? It is the number of inputs that will produce an output based upon the uncertainties. Now coming to the evaluating the uncertainties, what are the different types of uncertainties we can see? So uncertainty can be measured by the frequency of its occurrence and analyzing the contribution and resulting effect on the delivery performance. So what we are doing is that we are building a genetic algorithm. Genetic algorithm is having different steps. One is that chromosome representation, which we are giving for every genetic algorithm. Then what we are doing is we are going for initialization of population. So here we are going to use a set of decision variables. Selection strategy we are giving. What are the types of selection strategy we'll see? That is, a tournament selection is there. Method of selecting an individual from a population of individuals. And tournament selection involves running several tournaments among a few individuals, and we are choosing the winner. So I am giving the tournament selection. This is the this is the pseudo code which is responsible for tournament selection. And here choose the tournament size, choose the best individuals, choose the second best individual, choose the third best individual, and so on. So what are the benefits of tournament selection? It is having a lot of benefits. It is efficient to code, work on parallel architectures, allow the selection pressure to be adjusted, and so on. So what is the evaluation measure? So genetic algorithm, it will have a means of problem solution. Objective function is the driving force of genetic algorithm. In this research, instead of performing an analytical function, we are determining the performance of each solution. Okay, so we are having a fitness function which is used to calculate the solution and how well the fitness value is computed. For example, in this case, we are going to see about the production cost. Therefore, the fitness function is given as f of x equal to log of 1 minus xc by xp, where xc stands for the count of occurrence and xp the total values in the data set. Total manufacturing cost equal to, the formula is given as purchasing cost plus operating cost plus storage cost. And the objective function, what is the objective function? It is to minimize the total cost. So the total manufacturing cost, we are going to minimize it. How we are going to compute the total manufacturing cost is, first we find out the the purchasing cost, then the operating cost, then the storage cost. How we are calculating the purchasing cost is that purchasing cost is equal to Q into P, that is quantity of the material into unit of the price of the material. Similarly, the operating cost is equal to formula is N into CO, where number of units into average production cost, and SC, the storage cost, is equal to SQT into CS, where the stock quantity into the storage cost is done. So individually we calculate the purchase cost, the operating cost, the storage cost, and then what we do is that we try to add up everything and find out the minimization of total manufacturing costs individually. So if you are going to reduce this one, overall it will try to reduce the uncertainty and increase the profit. So uncertain variables, how we are constructing QI, PI, N, CO, SQT and CS. These are the uncertain variables. QI stands for quantity of the material, PI stands for unit price of the material, N stands for number of units made, CO stands for average production cost, SQT stands for stock quantity at a time, and CS stands for storage cost. So this is the chromosome representation which we are going to apply for a genetic algorithm. So this paper is advocating and proposing a new algorithm called as single point crossover uniform mutation genetic algorithm. So the proposed work considers uncertainty of cost in production scenario, develops an algorithm for managing uncertainty by minimizing the manufacturing cost by crossover and mutation operator. So what we are doing is step by step. First step is assign the population size. The second one is generate initial population. Third step is compute the fitness value, and then the steps are stopping criterion. When it is satisfied, it will break. What are the objective function, how it is used with weight values, that is considered. And when we take the tournament selection, which is the selection criteria, two individuals are selected at random and then it is selected into the mating. The steps further are perform the crossover and mutation, and after that we find out that we do uniform mutation and single point crossover. That is what is the basis of our algorithm. The best individual is then founded from the genetic algorithm tools and operation. So what is the discussion and result is that this algorithm is applied to production control system. Uncertainty is found out. It is affecting the profit margin. The input data is real time from UK based Astel computers. We got the input. This is the table that I am showing, and from this table we are generating new set of solutions for every generation, and at the end of 100 iterations the best chromosome of 9, 31, 5, 50, 70, 10 is obtained. This is generating an optimal value of 1229. So it's an optimal value, a total manufacturing cost considering all the uncertainty factors. We are getting this minimization of total manufacturing cost. And so when we see, these are the result oriented diagrams obtained by GA tool, and when you compare with the standard algorithms, it performs 13% better than NSGA1 and 18% better than NSGA2. So thank you for all for listening to this e-presentation.